When the world's armed forces need to pack a punch on the battlefield, they bring out the big guns. Modern artillery is an age-old solution adapted to today's military objectives. And when 21st century armies unleash a barrage of artillery fire, there's plenty of high-tech weapons to choose from. Artillery is one of the most fearsome weapons in modern warfare. Flexible and mobile, these high-caliber guns deliver destruction across the lines of battle, enabling friendly forces to attack while keeping the enemy pinned down. The basics of artillery are nearly as old as warfare itself. From catapults to cannons, the military objective was the same: shoot a projectile at the heart of the enemy from as far away as possible. But even the most powerful cannons were what the military calls direct fire weapons, which means they could fire only at targets that could be seen. The industrial age saw the development of more effective propellants, gun barrel technology, and high explosives. A new style of artillery fire was possible: indirect fire. Shells could now be fired up to 15 miles, well beyond the visual range of the gunners. This great leap forward in military technology led to terrifying results when it appeared on the battlefields of Europe in World War I. World War II saw the emergence of the armored vehicle as an antidote to the artillery revolution. The armored vehicle could protect its crew from incoming rounds. Improved artillery weapons were mounted on tracked armored vehicles to enable them to keep up with fast-moving tank divisions. On all sides of World War II, artillery crews rarely saw their targets. Instead, they relied on mathematical calculations to fire explosive rounds against distant enemy positions. On the receiving end, there would be little warning. Just dive for cover and wait for the shelling to stop. By the end of the war, artillery held the claim to the most destructive force in land warfare, accounting for about 70% of all World War II battle casualties. Artillery can be categorized into three basic types: mortars, howitzers, and guns. Mortars are considered the hip pocket weapon of the infantry. Lightweight and easily moved. A mortar team of 4 can set up and fire dozens of rounds in just minutes, and then move their position before the enemy has time to respond. Artillery weapons are designated by their bore diameter, the inner diameter of their gun tube. This is a 155 millimeter howitzer, meaning that its gun tube is 155 millimeters across, or about 6 inches. Some smaller howitzers, like these lightweight 105 millimeter howitzers, use a metal case behind the projectile to contain their propellant. Larger howitzers use simple bag charges instead. Fewer bag charges for shorter range. More bags for greater range. The range of a modern cannon is determined primarily by the amount of propellant used to launch the projectile. The length of the gun barrel matters too. The longer the barrel, the more time for the explosive to shoot the projectile forward. The configuration of howitzers is shaped by their mission. The smaller 105mm howitzers are a favorite of light mobile divisions such as paratroop and heliborne forces. Light enough to be airlifted by helicopter, the 105mm is used extensively by the 101st Air Assault Division. Other light units, such as the U.S. Army's Light Infantry Division, use the Humvee to tow them into combat. The 105mm howitzer can also be airdropped by parachute. This is the delivery method favored by the 82nd Airborne Division. Larger towed howitzers like this 155mm model are found in Marine divisions. A towed howitzer is much lighter than the self-propelled version of the same caliber. This is an important consideration for Marine divisions that must move all their equipment by ship and amphibious landing craft.
Sergeant, red bag. I see red, close. White bag. 7 white bag. Fire. Boom.
The backbone of today's artillery force is the self-propelled howitzer. They are most commonly found in the Army's armored and mechanized infantry divisions. The U.S. Army has favored tracked self-propelled howitzers since they have the best performance in tough conditions such as mud or snow. Other armies prefer their artillery mounted on wheeled chassis, which both reduces cost and affords greater speed. One example is South Africa's massive G6 howitzer, which employs a semi-automatic loader that can fire up to 4 rounds per minute. One of the most innovative wheeled artillery vehicles is the French César. Its 155mm cannon is mounted on a 6x6 cross-country truck chassis, offering excellent tactical and operational performance. Its signature tactic is to hide, fire, and scoot. The César can hide until an order is given, then quickly move into firing position and immediately launch its ammunition. It can fire 6 rounds and then retreat to take cover in under 2 minutes. César's effectiveness is based on its state-of-the-art weapon system. This system provides real-time fire control management, including muzzle velocity radar, GPS navigation, and instantaneous transmission of firing orders. The César provides direct, indirect, and counter-battery fire support. Its lightweight and compact design make it ideal for rapid deployment forces. Although tracked vehicles are slower than wheeled ones, they offer the ability to carry greater armor protection. The self-propelled howitzer looks much like a tank, but there are important differences. Tanks usually have their turrets mounted in the center of the chassis. Self-propelled artillery such as this M109 howitzer carry larger guns and have their turrets mounted in the rear. This position makes it possible for ammunition handlers to pass shells and explosive charges to the gun crew. The M109 howitzer can fire a 155mm shell at a distance of nearly 20 miles. Controlling this level of firepower and putting rounds on target requires the careful choreography of its 6-man crew.
You would have the gunner. He aligns the howitzer on the azimuth of fire given by the Fire Direction Center. You have the assistant gunner, who is an E4 or corporal. He elevates or depresses the tube to the appropriate quadrant given by the FDC. You have the chief of section, who initiates all of the commands to the individual howitzer crews. You have a number 1 man who loads and fires the howitzer when commanded by the Fire Direction Center. And you have the number 2 man who does the recording of the fire mission itself.
To protect ammunition being transported to the howitzer, the Army developed the Field Artillery Ammunition Support Vehicle, or FASV. The armored FASV protects the ammunition and has handling equipment to speed the loading of the M109 howitzer. One of the most significant advancements in artillery has been the incorporation of positioning equipment on the vehicle. The accuracy of artillery is dependent on knowing precisely where the battery is located in relation to the enemy target. In the past, this was done by laborious and time-consuming surveys. The current models of the M109, the A6 Paladin, contain their own state-of-the-art positioning systems.
This howitzer that you see is the M109 Alpha 3. The Paladin howitzer is an improvement over this in several ways. The biggest thing is that it allows each howitzer to carry with it directional, well actually a location finding capability, so that the howitzer knows where it is at any given time period.
Because of the time it took to calculate positions, howitzer batteries were lined up close to one another in order to share targeting data. Should an enemy pick up the location of these artillery lines, they could send a counter battery of artillery, and with several howitzers in the same location, they would likely score a hit. The Paladin with vehicle-mounted location systems can be placed in different locations, and each can calculate targeting data independently. Despite being physically separated, they can still send coordinated rounds to make simultaneous impacts on targets. The revolution in positioning systems has been matched by advances in the ammo fired by artillery. One of the most important new types of ammunition is DPICM. Normal projectiles are intended for a single target. DPICM is filled with small grenades and can devastate a much wider area. During Operation Desert Storm in 1991, the DPICM projectiles were called Steel Rain by Iraqi troops.
The high explosive round can do a couple of things. It can either detonate upon impact, or we can have it detonate in the air where it explodes from within, spraying shrapnel in a given location. The devastation that occurs on equipment and other things when those shape charges goes off is almost intolerable to try to survive under a barrage of DPICM. That is the munition of choice on the battlefield. When we were in Iraq, we captured some POWs during the war, and we had one of the leaders of a group of POWs come up to us and talk about the rain of artillery. And one of the statements that he made was, no more rain artillery, no more rain artillery. And they were speaking primarily of the devastation that they had experienced under the fires of DPICM.
Artillery has traditionally been an area attack weapon. Incorporating laser technology has permitted the development of projectiles such as the Copperhead, which can pinpoint targets. To guide a Copperhead round, a laser designator team is needed to see the target. In the U.S. Army, artillery forward observers in the Fire Support Team Vehicle, or FISTV, can perform this function. In the hammerhead mount over the vehicle is a laser designator, which shoots a laser beam at the target. The artillery system 10 miles or more behind them is instructed to fire its Copperhead round into the approximate vicinity of the target. The Copperhead can detect the beam reflected off the target and achieve pinpoint accuracy even on moving objects.
The Copperhead munition, though, is not something that we fire huge amounts of Copperhead out onto the battlefield and everybody's lasing at one time and individual vehicles start blowing up. It's more of an artillery sniper weapon where we would take out what we call a high priority target, maybe some sort of higher level command and control node, or something that would be very important to a higher level commander.
Another sniper-like munition is the 155mm bonus artillery round. Bonus is a top-attack anti-armor shell designed to strike armored vehicles from above, where they are most vulnerable. Each round carries 2 smart submunitions. As it passes over the target area, the submunitions are ejected from the shell. Once dispensed, they deploy spin-stabilizing wings and, using infrared sensors, begin to hunt out enemy armored vehicles. Bonus rounds work by delivering an explosively formed projectile warhead, or EFP. Once the warheads penetrate, all targets inside, including equipment, are effectively destroyed. Bonus shells are jointly manufactured by Bofors Defense and Giat Industries under the most exacting conditions. These rounds are currently being evaluated by the U.S. Army to determine their effectiveness for use with all 155mm howitzer systems.
What's FTC? Go ahead, 4. You should have the PTN representative. As far as what? Quadrant 3816. Quadrant 4817. All right. Safe. Don't feel the wind, so don't think you try and take 2 months to find a key.
In order to demolish a target, modern artillery requires an extraordinary degree of coordination. Three elements are especially important. The howitzers and other weapon systems are the artillery's muscle. The Fire Direction Center, or FDC, is the brains of the artillery, conducting the actions of scattered artillery batteries. And finally, artillery radars and forward observers serve as the eyes of the artillery. For the artillery to deliver its fearsome firepower accurately, all these systems must act in unison with one another.
We have to have good directional data, and our survey teams do that for us. We also have the people that have to maintain the artillery systems, our mechanics, and that's a very large aspect of our job. We have to have meteorological data, weather data, that enables us to know what's going on in the environment that the projectile is flying through, and we have metro systems that do that. We have target acquisition capabilities such as our radar systems, and they're a very important part of the artillery total systems approach to getting our job done.
The basic unit of the artillery is a platoon, generally consisting of 4 howitzers. Coordinating this platoon is a Fire Direction Center located nearby. For the Fire Direction Center to provide accurate targeting instruction to the howitzers, information on the enemy's position is vital. Target data can be gathered from a wide range of sources. The location of enemy artillery is determined by the firefighter's radar. This radar can track the flight path of incoming artillery and then calculate the location of enemy positions. During the 1991 Gulf War, this radar was able to determine information so quickly that the U.S. artillery could open fire on Iraqi artillery positions even before their incoming rounds had landed. For targets closer to the battle line, fire support teams provide key data. These forward observer teams can be on foot, but in maneuver units, they usually go into battle inside the FIST-V vehicle.
FISD is the fire support vehicle. That houses the eyes of the artillery. The fire support officers who travel with the mechanized division, the armored division, it has a laser system that enables them to spot the target, determine a bearing, a direction to that target, and then a range to that target. It gives us greater accuracy. It gives us greater mobility. The communication systems that are inherent to that system give us better command control capability with that system.
It is the coordinated action of the fire direction centers, the target acquisition systems, and the artillery batteries themselves that make modern artillery so formidable on the modern battlefield. Rocket artillery is as old as gunpowder itself. There was a revival in the use of rockets for artillery during World War II. This German multiple rocket launcher is a forerunner of today's rocket artillery systems. Multiple rocket launchers can bombard a target with high explosives in a matter of seconds. A single vehicle has the simultaneous firepower of a whole battery of conventional guns. The South African battle lure is a good example of this type of weapon, firing a 122mm rocket to a range of a dozen miles or more. The battle lure's wheeled chassis allows it to deploy rapidly over great distances, delivering its powerful barrage anywhere on the battlefield. An even more powerful weapon is the U.S. Army's M270 Multiple Launch Rocket System, or MLRS, which is mounted on a tracked chassis. Each MLRS launcher is equipped with 12 rockets. The rockets are armed with 644 submunition grenades. A single rocket from an MLRS can devastate an area the size of a football field. MLRS launchers carry onboard navigation systems. At the beginning of the mission, the MLRS crew drives up to a pre-surveyed spot where it obtains its location data. From that point on, the navigation system keeps precise track of where the vehicle is located. When the target data is received by the MLRS launcher from the Fire Direction Center, it is entered into the vehicle's computer, allowing the launcher to automatically target enemy positions. Due to automated loading of its ammunition, the MLRS can operate with only 3 crewmen. This small crew can deliver firepower that would have required an entire battery of World War II artillery. In early 2003, the U.S. Army fielded upgraded MLRS in support of Operation Iraqi Freedom. Artillery is one of the oldest and most traditional weapons of land warfare. As simple as the basic weapon may seem, technology has revolutionized the firepower of the artillery strike. Advancements in computer controls, navigation systems, radars, and ammunition have ensured artillery's central role on the modern battlefield.